Hello, my faithful followers. Welcome to Wednesday of the end of the semester versus the beginning of the semester, which, who'da thunk? Good morning, Schwartzmeyer. Good morning, Michael. 11:25. Do you guys eat lunch at noon? Or do you guys eat lunch at all? I always get hungry during teaching. And I wish I could just eat my lunch while teaching, but obviously that's not a good idea. Okay, that makes sense. 9:30 to 10. That's actually not too late. I know some people's sleep schedules have gone way off kilter with COVID. Personally, if I'm not scheduled, I feel awful. I feel so unmotivated. I feel like nothing gets done. I really don't like myself. So I try to stay as scheduled as possible. It's nice teaching class, actually teaching live, because that really helps. Hopefully that helps you guys. I don't know. I know those of you who still watch live. I appreciate you talking to me. I appreciate it. I really do. Hopefully the synchronous format is useful, and the fact that it's recorded is also useful. I'm trying to figure out how to keep some of the stuff that I've done remote back into the classroom in fall. I don't know, what are some things you guys really like about online that you would want to keep? Homework tonight is it's not at all as long and annoying and arduous as last week's homework. It depends on how well you know the concepts. I don't know. I would say give it a couple hours at least. Workload. I mean, I think the workload for this class has been typical for a given semester. Not having to walk, not having to commute is actually a lot. Online live Zoom allows for more student. I love the chat. I think you're right. Like, I had someone explain it to me where it feels less like interrupting when you type in a question versus raising your hand. Yeah, Squiddy, you should have enough time to do the homework if you started after class today. Like I said, it's not nearly as long as last week's. There are some row operations to do, but they're different. I mean, they're the same, but they're the same types of row operations, but it's just easier. I don't know. It just seems to be less. Yeah, there's just less of them to do. So yeah, you should have time. People have been asking some really good questions on this homework, which is awesome. Very insightful. But yeah, so the chat has been great. And I don't know how to bring that into the classroom, but I'm going to figure it out. Because it really, I think from a student perspective, typing a question in the chat feels less interrupty than raising your hand, or less scary than raising your hand. I know whenever I talk in the classroom as a student, I get really nervous, and I mean, public speaking is not my forte. I've gotten better while teaching, but anytime I'm not planning on talking in front of people, it's just my heart races and I get so nervous and I just lose all of my words and it's really nerve-wracking. And so I imagine the chat kind of helps remove some of those barriers for you guys. Michael, this class is usually taught in, so usually it's in like NSC, if you guys even know what NSC is. But it's usually taught in like a classroom that seats about 100. And there's typically, it's capped at 60 people. The section's capped at 60 people. So it's usually a smaller lecture. When I first came, we were at 80 people, and now we're down to 60 people a section. But by the end of the semester, you've got like 30 people that show up, maybe 20, especially if it's 8 in the morning, which I've always taught the 8 in the morning sections, which are rough. But yeah, it's typically 60 people. So, it's not a small group. And I still need to figure out what the in-person interaction looks like versus the, I don't know. I need to figure out. Anyway, it's class time. So let's go ahead and start. If you guys have any suggestions for how you would prefer class to look like when we transition back to in-person, please let me know. Like, when you fill out the course evaluations, tell me like exactly, like, I really would have loved to see this in person, or I really think this would be a great idea to do in person. I really want you guys' feedback. I try to incorporate feedback as much as possible. Last caveat, Benny, when I typically have it in person, I typically do it so that I teach a little and then I have short, small activities where students work on that small activity and then they can ask questions from the people around them. I can't really do that in Twitch, obviously. And I didn't really want to do that in Zoom either, because I didn't want to deal with Zoom going back and forth with breakout rooms. So I transitioned to this. I don't know. I think I've enjoyed this version of class as well. I know it's different. I know it really is different. But yeah, like I said, if you have any suggestions on what you want to see still be in person or still exist when we go into person or not, please let me know. I need to restructure everything, which is a lot of work for me, but I enjoy doing new things. I enjoy trying new things. I enjoy trying different ways to help out students and enforce activities and the content. And my experience too, FT, which is why I didn't want to deal with the awkwardness of Zoom, of everybody just not having their cameras on and no one talking, because it's different. It's not like it's in person. And Zoom is not a replacement for in person. Anyway, let's go ahead and start. I could talk for a while on everything that I've had to change and learn and all this fun stuff. Okay. So, and thank you, Schwartzmeyer. I really appreciate it. Okay, let's go ahead and begin this one. Okay, so on Monday, I introduced LU factorization. And LU factorization is where we are going to apply 3 row operations for a 3x3 specifically. 3 row operations, the same ones every single time. So first I'm going to say row 2 equals row 2 plus some multiple of row 1. And then I'm going to say row 3 equals row 3 plus some multiple of row 1. And then my third row operation is going to be row 3 plus equals row 3 plus some multiple of row 2. Okay, so for this matrix, specifically, if I applied these row operations, it would look like this. I would say row 2 equals row 2 plus negative 2, row 1. So here L21 would be negative 2, which, remember, this is what's called a multiplier. It's going to show up in my L matrix. And then for my second row operation, I would say row 3 equals row 3 plus 4/3. Come on, pen. 4/3, row 1. so L32, or 3-1, not 3-2, would equal 4/3. So if I do those row operations, I'm going to end up with this. Row 1 doesn't change. Row 2 now becomes the 0 that I want. I end up with another 0 here, and I end up with a 5. And then for row 3, I get 0, 3, or 32/3 and 7/3. So there's my first two row operations. AP, I will have those details next week. It's a very good question. Very good question. I will have those details next week. I'm hoping the answer to that question is yes, but I don't make all decisions. We meet as instructors on Thursdays, so Dr. Ellie, Dr. Spotto, and I meet on Thursdays. I came up with 4/3 because whenever you're looking for these multipliers, you're just going to take this number divided by this number. So note this -2, or this 2 comes from 6/3. And then I switch the negative or positive depending on which one I need it to be. Same thing here. I just take 4/3. That's where I come up with the 4/3. What do I need to multiply this row in order to make this a 0? Okay, so now my last row operation. Row 3 equals row 3 plus some multiple of row 2. So my goal is to make this a 0. What I typically do is I take this number and then I'll divide it by this. However, if I do that, 32/3 over 0 gives me something, a over 0, which is infinity, not defined, however you want to describe it. Not defined, infinity, whatever mathematically. It just means that mathematically I cannot do this. I cannot apply this row operation. I need to stop here and I can no longer move forward. My LU factorization has broken down. So we need to find a way to overcome this. So today we are going to learn about another type of factorization called PLU factorization. PLU factorization is essentially the same thing as LU factorization, but we're going to add in 2 more row operations. And these are going to be row swaps. So LU factorization, we have those 3 row operations. That's it for a 3x3. For PLU factorization, we're going to have a total of 5. The first one is going to be some row swaps. The second one is going to be row 2 equals row 2 plus some multiple of row 1. The third one is going to be row 3 equals row 3 plus some multiple of row 1. My fourth one is going to be another set of row swaps. And then 5 is going to be row 3 equals row 3 plus some multiple of row 2. So note, this, and this are the same as LU factorization, but PLU adds in these 2 row swaps. And the goal of these row swaps is to make sure that I don't end up with a 0 in what's called the pivot location. Because if I have a 0 in the pivot location, then I'm stuck. I can't move forward unless I do some row swaps. So the goal of this first row swap is to get the largest number into the 1, pivot location. The goal of this second row swap is to get the largest... My handwriting is so much nicer on paper with a pen. The stylus is like, it's too smooth. I mean, let's be honest though, my handwriting isn't that clear to begin with. Into the 2, pivot location. It used to be beautiful until college. So the goal of my first row swaps is to get the largest number into the 1, pivot location. And then I do my row operations for column 1. And then I do another set of row swaps to get the largest number into the 2, pivot location. And then I do my row swaps for column 2. Okay, so let's go ahead and apply these to this matrix. So I'm going to do PLU factorization. I'm going to delete this so we can keep these row operations here. Okay, So, row operation 1. I'm going to do row swaps to get the largest number into the 1, 1 pivot location. The 1, 1 pivot location is this here. When I talk about get the largest number, I'm talking about this first column. And I don't care about the sign. I only care about the magnitude. So I've got 3, 6, and 4. The largest of those is 6. The largest of those is the 6. So that means I'm going to swap rows 1 and 2. What this is going to do is now I have my 6 in my pivot location. And I'm not ordering them. I'm not ordering them in size and magnitude. I'm not saying 6, 4, 3. I'm just finding the largest one and just swapping those 2 rows. There we go. I've got my 6 here in the pivot location. I have my largest number from column 1 where I want it. My second row operation. Row 2 equals row 2 plus some multiple of row 1. Now this multiple is going to be 3 over 6. Or 1/2, specifically negative 1/2. So L21 is going to be negative 1/2. And then my third row operation. Row 3 equals row 3 plus some multiple of row 1. It's going to be 4 over 6, or 2/3. So L31 is 2/3. Once I do this, row 1 doesn't change. Row 2 becomes 0, 0, and negative 5/2. So I still have that 0 that shows up, but that's okay. We're good, because we're doing PLU factorization, so we don't have to worry about that. And then 0, 32/3, and 17/3. Okay, so I've done 1, 2, 3. Now my second set of row swaps. So now my goal is to do some row swaps to get the largest number in the 2, 2 pivot location. So here's my 2, 2 pivot location. And it turns out when I do this, I'm going to ignore, not how you spell ignore, column or row 1 for this. I'm only interested in all of the values below my second row. So I'm choosing between 0 and 32/3. You may have guessed 32/3 is bigger than 0. So I'm swapping rows 2 and 3. Nope. So now I have my largest number in my 2, 2 pivot location. And it's not, like I said, it's not the largest number overall. Actually, it is. But I'm ignoring column or row 1 for this. AP, that's a good question. So the strategy is to use whichever method we tell you to use. But in general, you can still try LU factorization, and LU factorization will work most of the time. But PLU factorization will work all of the time. So in practice, you'll probably know a little bit more about your system. So in practice, you probably know a little bit more about your system. You might use a different method. You use the method that works the best for your situation. So that's a good question. LU factorization will work most of the time. One of the things about PLU factorization is we end up with more fractions. When we do PLU factorization, we're going to end up with multipliers that are always 1 or less. So one of the benefits of using PLU factorization is you end up with smaller numbers, which means they're potentially more predictable. There's less chance for you to have a wide range in magnitude. So you really use the method that works best for your given situation. And I'll notice that. I'll mention that again later on. But that's a good question. Okay. So I've done 1, 2, 3, 4. My last row operation, I'm going to replace row 3 by saying row 3 plus some multiple of row 2. Note in this instance, this multiplier is 0. I'm still showing the row operation because I still want to indicate that L32 is going to be 0. So I want it to be complete. So I'm still showing all of my row operations. I'm going to zoom out a little bit so we can see it all. So there we go. We've got PLU factorization, where instead of us having 3 row operations, we are going to do 5 row operations, where we include these row swapping that occurs. Okay, so now I need to put together all of my matrices. I need to put together P, I need to put together L, and I need to put together U. U is still your result that you get after you apply all of your row operations. So whatever you end up with is going to be U. So you do your 5 row operations. There you go. You've got U. Woohoo! That's the easy one to put together. For LU factorization, it was pretty easy to put together L, right? You would just start out with something like this. You would say L21 or negative L21 goes here, negative 231 goes here, and negative 32 goes there. Don't forget to change the sign. For PLU factorization, it's not as straightforward. Okay, so let's go ahead. Flora, that's a good question. You want the biggest magnitude. You don't care about the sign, you just want the biggest magnitude. So if you have to decide between 10, negative 12, and 5, you're going to choose the negative 12 because it's the largest magnitude. Okay, so we already know what U looks like. Let's go ahead and put together P. P is going to be identity. And then we're going to apply the same row swaps we did in row operation 1 and row operation 4. Starting from the top to the bottom. So in row operation 1, I swapped rows 1 and 2. So if I swap rows 1 and 2, it looked like this. And then I'm going to do this row operation. Swap rows 2 and 3. So then I'll do this row swap. Nope. So with P, when you put it together, you're going to start with identity. You're going to apply the same row operation you did first, your first row swaps, do that on identity, and then apply the second row swaps. Whatever you end up with after that is going to be your final P matrix. So P is just going to be your row swaps done on identity. Done on identity. So we've got U, we've got P. L is the trickiest one to put together. To put together L, what we need to do is we need to start at our last row operation and work our way back. So we know L is going to look something like this. So first thing we want to do is insert L32. So it's a positive 0, so I switch the sign, so I'm going to get a negative 0. Which is ridiculous, but I'm going to leave it in there just to indicate that we've purposely put in that 0 and it doesn't just happen to be there. So I've done that. Now I'm going to go up to this row operation here. So I'm going to do this row operation. I'm going to switch rows 2 and 3. Whoop. And then I'm going to insert these two. L21 goes here, so a negative 1/2 becomes positive 1/2. And L31 goes here, and positive 2/3 becomes negative 2/3. So it doesn't matter whether or not I swapped these rows or not. I'm still going to put them in their typical location. So in 2-1, 3-1. And the last thing I'm going to do is I'm going to do this row swap. So swap rows 1 and 2. And what we end up with is L. So now we've got U, we've got L, and we have P. So U is straightforward. You do all the row operations, and then you're done. P, you're going to start with identity, and you're going to do the row swaps. Row swap 1 and row swap 4. Or row operation 1 and row operation 4. For L, we are going to work our way back through those row operations. We start at this one, insert our L32, we swap the rows that we swapped for 4, we insert L31 and L21, and then we apply our last row swap. So we swapped rows 1 and 2 because that is the first row operation we did. So we got to work our way back through all of the row operations. Okay, so one thing to note is there are some caveats when it comes to PLU factorization. If we look at PL and U, I'm just going to copy U over. If we look at L, note L is not a strict triangle matrix. The -0 is not necessary. I wrote the negative, I followed it through, so we know that 0 is placed there on purpose. It's not just thrown in there. So AP, I'm going to explain why I go through the entire process. So note, L is not a strict triangle matrix. A lot of times when you see PLU factorization done, they are going to do L as P times L. So if I multiply P times L, what this does is this will rearrange my rows of L, where it'll put, so row 1, column 1 gives me a 1, row 1, column 2 gives me a 0, row 1, column 3 gives me a 0. Row 2, column 1 gives me a -2/3. Row 2, column 2 gives me a 1. Row 2, column 3 gives me a 0. And then this one, so row 3, column 1 gives me a 1/2. Row 3, column 1 gives me a 0. Row 3, column 2 gives me a 1. So what this does is if I multiply P times L, it gives me L as a strict triangle matrix form. So a lot of times when we do PLU factorization, people will write U like this, like normal, and then they'll combine P and L so that it gives you L as a strict triangle matrix. So that's why we need to account for P in both P and L. Because if we don't account for P in L completely, when we do this multiplication, P times L, it's not going to give us L in a strict triangle form. And when you do it on paper, then you kind of know what's happening behind the scenes and you don't really need to account for everything. But I really want you guys to account for everything, because if you check your work in MATLAB and you multiply all your matrices together, you really want to make sure you have all of your ducks in a row, because MATLAB's not going to know that you did a minor trick on paper. MATLAB's going to know, hey, this is what you got for P, this is what you got for L, this is what you got for U. You typed it in. So you need to know all of these pieces. So a lot of times you will see L as a strict triangle matrix. And that's not that big of a deal, because what happens when we do this is if L is a non-strict triangle matrix, if we say U times L, then we end up with A. A lot of times you'll see PA equals LU. So if you have P incorporated into L, where L is a strict triangle matrix, this is what you're talking about. If you have L that's not a strict triangle matrix, then you have this. And we'll see why we care about that when it comes to solving systems using PLU factorization. Okay, so that's our process. Those same 5 row operations, and and you construct P, L, and U. So if we had just done if we just inserted, here, let me do it over here. So if we had just inserted our values, we'd end up with 1, 0, 0. We'd end up with the positive, negative, 0, 1. This is what we would have ended up with if we just plugged in our L values like we did for LU factorization. If I pull this over and compare these, they're very similar. They contain all the same numbers, but note these two are switched. And that's because we did our row swaps. So they're very similar, but there are these subtle differences that we get with PLU because we do row swaps. Okay. Okay, let's go and solve a system of equations. So let's say we have this as our system. We have AX equals B. And you want to use, or you're told to use, PLU factorization in order to solve the system. So I'm going to show you what it looks like for LU factorization, and then we will do PLU factorization. So for LU factorization, this is another practice. We would first say row 2 equals row 2 plus, in this instance, 5 halves row 1. So L21 is equal to 5 halves. Our second row operation would be R3 equals row 3, in this instance, minus 5, nope, thinking of the wrong one, plus 1 row 1, so L31 equals 1. If I do those row operations, row 1 doesn't change. Row 2 now becomes 0, negative 33 seconds. And 3. And then row 3 becomes 0, negative 1, and 7. My third row operation is going to be row 3 equals row 3 plus some multiple of row 2, in this instance 2 33rds, and it's going to be minus 2 33rds. R2. Hold on, Benny. L32 then becomes negative 2 33rds. So Benny, all you do to find L values is cancel first term in row. So you are finding your L values by doing your row operations. So first you want to make this a 0. Then you want to make this a 0. Once you do those, then you want to make this a 0. But no, we have to do these same row operations. It's always row 2 plus some multiple of row 1. It's always row 3 plus some multiple of row 1. It's always row 3 plus some multiple of row 2. So once we apply this last row operation, we end up with 2. Row 1 doesn't change. Oh my gosh. No. 2, negative 5, 2. 0, negative 33 halves 3. And then row 3 becomes 0, 0, 75 11ths. So this ends up being my U. L is constructed using my multipliers. So it always starts out looking like that. I insert L32, change the sign, so 2 33rds. Insert L31, which becomes a negative 1. Insert L21 equals, it becomes a negative 5 halves. And it doesn't matter which order in which you enter those in, as long as they're in the right spot. So given AX equals B, I've taken A, I've broken up into L times U. So if I was to solve this system of equations, I would rewrite it as LUX equals B, break it up into two pieces, LY equals B, UX equals Y. And then I would solve those pieces. So I would have L y is my unknowns in this one, equals b. B is 15, negative 15, 0. So this first one tells me that y1 equals 15. If I plug that into my second one, it tells me that y2 is going to be 45 halves. If I plug both of those into my third one, it tells me y3 is equal to 150 over 11. Once I have my y values, I can plug that into ux equals y. So u ended up like this, 2, negative 5, 2, 0, negative 33 halves. 3, 0, 0, 75, 11. X is my unknowns. My y values, 15, 45 halves, 150 over 11. I can see this 11 shows up in both places, which is great. That means I'm going to end up with whole numbers, most likely. So x3 ends up being 2. Plug that into this one. Tells me that x2 ends up being negative 1. If I plug those into this one, it ends up that x1 equals 3. So most of the time, not all the time, but most of the time your solutions are whole numbers. We might have fractions on our way there. Not most of the time we give you problems that have whole numbers just because it's easier to deal with that way. So keep that in mind as you're going through your homework, as you're going through your exam. Thought. Sometimes you might see small fractions, depending on the problem, but for the most part, things should be whole numbers. Okay, so if I was solving the system of equations using LU factorization, that is what I would do. I've got my 3 row operations. I've got U and L. Break it up into 2 sets. Ly equals B, Ux equals Y. And these are nice systems to find because I have my nice triangle of zeros in both instances. Okay, so now let's see what it looks like to do this with PLU factorization. Very similar. Very similar. Except now I have 5 row operations. So my first one is to get the largest number in magnitude in the 1, 1 location. So I'm looking at 2, 5, and 2. The largest numbers of those is 5. So I'm going to take row 1 and replace it with row 2, or swap rows 1 and 2. When I do that, I end up with this. Now I do my elimination steps. So I'm going to say row 2 equals row 2 plus some multiple of row 1, in this instance 2/5. So L21 over here is 2/5. Note it's similar to 5 halves. Not the same, but similar. Typically we'll see the same numbers appear on both sides, or scalars of our numbers. So my third row operation is row 3 plus some multiple of row 1, which is going to be negative 2/5. So L31 is negative 2/5. Not the same as it is over here, not even the same numbers. But once again, we're not applying the same row operations. We'll still get the same final result, the same final x value, solving our system of equations. But the process to how we get there is a little bit different. So after I do these row operations, I end up with, row 1 doesn't change. I end up with 0, negative 33/5, and then 6/5. Then I end up with 0, 28/5, and 29/5. Because we are doing that row swap with the largest number in our pivot location, we're going to end up with numbers less than 0. We're going to end up with more fractions. Yeah, that's just the way it is. Okay, then number 4. I'm going to do row swaps to make sure the largest number is in my 2 location. So I'm looking at these 2 numbers, 33/5 or 28/5. Once again, you don't care about the sign. All you care about is the magnitude. So 33 fifths is the largest of those two numbers. So I'm going to swap row 2 with row 2, or do no row swaps at all. Which happens in LU factorization, that's fine, or PLU factorization, that happens. We just keep moving forward. Keep in mind, though, that we're keeping track of all of our row operations, even if we didn't do anything. And the row operation 5, I'm going to replace row 3 by saying row 3 is some multiple of row 2. In this instance, it's going to be 28 fifths over 33 fifths. Or L32 ends up being 28 over 33. When I do that row operation, I end up with -5, -4, -2. 0, -33 fifths, and 6 fifths. My third row, I end up with 0, 0, and 75 elevenths. So here is my U. My U matrix is my final result, just like it was with LU factorization. Note, these are both my U matrices. This is my U I got from LU factorization. This is the one I got from PLU. They should be different if you did row swaps. If you don't do row swaps, they should be the same. If you didn't, they should be different. But they are related. You can see common numbers that show up in each one. Maybe you might just have a scalar multiple of another. So, Dan, so it says row 2 swap with row 2. And in fact, I do no swaps. The largest number is already in the 2, 2 location. So I'm just keeping track that I did that. Okay, so I've got U. Now I'm going to go ahead and construct P. P starts out with identity. My first set of row swaps, I swapped rows 1 and 2. So I swap rows 1 and 2. I'm going to do this in place. And then my second set of row swaps, I did nothing. So there's my P. P is just from my first row swaps, I just swapped rows 1 and 2 because I didn't have to swap any rows for my second one. Okay, now we've got L. L starts out like this. I'm going to insert L32 and change the sign so it becomes -28/33. Then I swap my rows. I don't have to do anything because I didn't do any row swaps. Then I insert L31 and L21. L21 always goes here. 2 fifths becomes -2 fifths. And then L31 becomes +2 fifths. And then my last operation is to swap rows 1 and 2. So these two switch places. Once again, I'm going to do this in place. 1, 0, -2 fifths, and 1. Okay. So there's U, there's P, there's L. If I did P times L, I would end up with this. Okay, so here's L as a non-strict triangle. Here's L as a strict triangle. That's very important because that's going to dictate how you move forward next. So we have L, we have P, and we have U. Now we want to solve our system. If we have L as a non-strict triangle matrix, it turns out we do the same thing we did for LU factorization. We write LU, x equals B, break it up into 2. Ly equals B, Ux equals Y. If we have L as a strict triangle matrix, we essentially have PL times Ux equals, and then we need to do PB. So if we have L as a strict triangle matrix, we essentially have PL in here. To account for the fact that P is combined with L, we need to multiply B times P. And all that does is just rearrange my rows of B. just like it did for L. So if L is a strict triangle matrix, we have to do this. We have to multiply B times P in order to account for that. If we do not have L as a strict triangle matrix, we don't have to account for P at all, because P is already accounted for when we construct L. Essentially, what we do when we have L as a strict triangle matrix is we unaccount for P. Kind of. And there's a reason for this. There's matrix math that goes behind the scenes, and if you want to, I can show you the math. I have extensively sat there and stared at Plu factorization, trying to figure out the best ways to explain it. This is what I've come up with over the last 4 years. But I have sat down and I have stared at the math. And so I'm not showing you guys that here because I just want it to be as applicable as possible and to show you the process in order to actually do the calculations. But if you want to, I can show it for you later in office hours. So when finding L, you can first just plug in the multipliers and then they apply it. So you have to do it in that order. AP, you have to do it in the order. You have to plug in L32 first, and then do the row swaps from step 4, and then plug in L31 and L21, and then do the row swaps from your first one. It needs to be in this same reverse order. To construct P, you go this way and just apply the row swaps. To construct L, you go from the bottom to the top. So on your homework, you will be asked to do it a certain way. You'll be asked to do LU factorization or PLU factorization, same way on the exam. The exam's not fully written, but we will tell you a specific one. I will let you know which one that is during our review, when everything's written. I'll know which one you need to focus on. When it comes to this method, or this one, pay attention to the way that the problem is written. If you are asked to find your PLU factorization such that L is a strict triangle matrix, then you need to do it this way. If not, don't worry about it. You'll see some of my examples written out this way from the past. I've tried to make it separate this year moving forward, but I want you to be aware of both. Okay, so let's go ahead and do this. Okay, so first things first, if we have LUX equals B, if L is a non-strict triangle matrix, we set it up the same way. Ly equals B ends up being this, -2/5, 1, 0, 1, 0, 0, 2/5, -28/3, 1, y equals b. B was 15, -15, and 0. This second equation tells me that y1 equals -15. This first one tells me that y2 is 9. And this last one, if I plug in those other numbers, it tells me that y3 is 150/11. So AP, that's a really good question. Your fourth step is never going to be swapping rows 1 and 2 because you ignore row 1. Good question. You're ignoring row 1, so it's never going to be swapping rows 1 and 2. Once I have y, I can plug it in to get ux equals y. U looks like this. Nope. Wrong side of my sheet. U looks like this. -5, -4, -2, 0, -33/5, 6/5, 0, 0, 75, 11. X is my unknowns. My y values, -15, 9, 150/11. Cupcake. Sorry. So this and this tells me that y1 plus 0 equals negative 15. If I plug that into this one tells me that negative 2/5 y1 plus y2 equals 15. So I'm just solving these system equations. I'm not showing you my work to save time, but that's how you would do it. You just write your system equations and you solve. You should have one where you have one unknown, an equation with 2 unknowns, and another equation with 3 unknowns. So this last one tells me that x3 ends up being 2. This last one will tell me that x2 ends up being negative 1. And this first one will tell me that x1 ends up being 3. Which, as I expected, is the same results I got using LU factorization. Okay, so that's what it would look like if L was a non-strict triangle matrix. Keep in mind your y values are going to show up out of order, and that's fine. Just keep that in mind. If you had L as a strict triangle matrix, it would look like this. You would have L as a strict triangle matrix. You would have Y. And then you have P times B. P ended up looking like this. And B was 15, negative 15, 0. When you do P times B, what it's going to do is it's just going to rearrange your values of B. So this first one is going to be negative 15. The second one is going to be positive 15, and this one's going to be 0. So if P has rows 1 and 2 swapped, it's just going to swap rows 1 and 2 in B. So that's what it does. Okay, so I've got P times B. So then I can solve my system. Here's my right-hand side, left-hand side, right-hand side. This one tells me that y1 is negative 15. If I plug that in, this will tell me y2 is 9. And this one will tell me that y3 is 150 over 11. Note, I got the same y values over here. You're going to get the same results. It's just going to be slightly out of order because you have the row swaps included into L. So then you put together ux equals y, negative 4, negative 2, 0. My y values were negative 15, 9, 150 over 11. This last equation, once again, tells me that x3 is 2. This one tells me x2 is negative 1. And this one tells me x1 is 3. So I get the same answers for x every single time, regardless of the path I come from. Regardless of whether or not I use LU factorization, PLU factorization with L as a strict triangle matrix, or PLU factorization with L as a strict triangle matrix. I still get the same x values. But you need to keep straight where everything is coming from, what matrices are you working with. You can always check your answers in MATLAB. So here, if you say L times U, you're going to get A. If L is a strict non-triangle matrix, if you do L times U, you'll get A. If L is a strict triangle matrix, it turns out you have to do L times U. That will equal P times A. So you can always type your answers into MATLAB and do the calculations in MATLAB, the matrix multiplications, to check your answers. But you got 3 paths. Note, LU factorization can be used most of the time. There are some limitations, like we saw. PLU factorization can be used every time, as long as you have a solution. So like if you have an infinite number of solutions or no solution to your system, then you can't use that method. And we'll talk more about that next week. But yeah, so pay attention when you have PLU factorization. Is L strict triangle? Is L not strict triangle? Okay, so with that, we're done. your set of videos for Friday. There's more videos this next week. I'm sorry. There's just more theoretical concepts to talk about. I mean, longer in terms of like you have 30 minutes instead of 20 minutes, so it's not that big of a deal. But yeah, that's it. Next week is our last set of material. We've got some theoretical concepts on Monday, and then we'll do eigenvalues and eigenvectors on Wednesday. And then the week after that, we're going to do review, and then we'll be done. And you can do it. I believe in you. Yeah, I think about everything you've learned. I know you're in the thick of it. It's been great. Okay, are there any final questions before we head out for today? If not, I will see you guys next week.